I wish I was offering, some secret kernel of advice, but I wanted just to share my story of what it was like to be an engineer for 3 years at my first job, and what I was scared of versus what reality was like. Again, I was really scared that I had to know all my equations at all times. All right, welcome to today's video. Today's topic, being a loser in a white GT4. All right, today's topic is a day in the life of a mechanical engineer. This is speaking from experience. So many of you may be in undergrad or grad school and you want to know what life is going to be like as a mechanical engineer once you're employed full time. So I just want to give you a little summary of what my life has been like. We're going for a little drive. There's a big storm out here, so I just want to survey some roads. And while we're doing that, we'll have a little chat. So I think one of the biggest misconceptions in school is that when you go into industry, you have to know like every equation in every class that you learn on the spot. Like Navier-Stokes, go. Your boss is gonna be like, what's that equation? Or whatever. That's not the case. It obviously will help if you're in like a meeting, you're like, oh, like we should run a quick napkin math on a thermal analysis, what is like conductive heat transfer formula, blah blah, but like it's pretty rare that you're gonna run into that situation. But so a day in the life, when you get like your first job out there, you're not gonna have a lot of responsibility as a mechanical engineer. You will be given a lot of like menial tasks, so to speak. So for example, maybe you're going to design like test fixtures or jigs, or you'll do some like light machining work at your job. So I'll give you an example from my first job. And for me, I was in defense contracting, so I can't speak if you're working in some like dishwasher industry, so to speak. But I go to work, I talk to my senior engineer boss and say, hey boss, like, what do we need done? And I'll say, oh, like, I want you to take care of this, thermal analysis. Why don't you talk to the electrical engineering team, figure out what the circuit board, how much power it's consuming, and go into SolidWorks, mock it up, apply material properties. And I wanted to give like a rough pass of whether, this widget you're making is gonna like melt or reach some like critical junction temperature, on like a circuit board. And so what you'll do is like you'll play in SolidWorks simulation for like a week or whatever, and you'll do all your CAD designs, and you'll say, hey boss, like, what do you think of this? And he'll give some feedback. And he's really there to shape you into becoming a good mechanical engineer. None of these employers expect you to like hit the ground running as like a PhD professor mechanical engineer who can like function by themselves without any input from senior or principal engineers. Like you're really there to adopt company policy and just like tricks of the trade. Every engineering firm has their way of doing things, and so they want to like teach you on how they do it, best practices. They'll be like, oh, like, hey, when we make our engineering drawings, this is a template that we use, or like we call out these datums, we use this GD&T, we use this, we use that, so make sure whenever you're working here, you abide by these practices. So some cool things you might do is like design something in SolidWorks, then maybe you'll use a company like Proto Labs or some like rapid prototyping website. Proto Labs comes to mind. There's some other ones out there that I already forgot. It doesn't matter. And you'll either make the part yourself in the machine shop, or and if it's like a one-off, you'll make it yourself. But if it's like 100 pieces, you'll use a third-party company. So it'll be your job to design the part, make an engineering drawing, check your engineering drawing with a senior engineer to make sure that everything was to spec. And really what that drawing is there for is to give the machinist or the creator of the part, you know, the best shot at accurately creating what you wanted. You might think to yourself, oh, you know, I'll just upload the CAD file and they should just go off that. Well, you know, if they don't have to pull a tight tolerance everywhere, well, that's just a waste of money. You know, if you don't need a plus or minus 1 mil on your entire part, and you know, only one feature needs to be plus or minus 1 mil, well, that's important to the machinist to know. Versus everything else can be plus or minus, like say, like an eighth of an inch. You know, if you were like doing framing on a house or whatever. Kind of extreme examples here. You will interdisciplinary work with other engineering disciplines like digital engineers, electrical engineers, hardware engineers, RF engineers. Obviously, depending on where you're working, you'll work with program managers. They'll say, hey, you know, how's progress on your task? You'll meet with them like maybe like once a week. You'll give an update. Maybe you'll make some PowerPoint slides. You'll take, you know, screen grabs of your design, and you'll pretty much talk to why you did stuff. You know, one of the best pieces of advice, you know, that I can give to you as an engineer is you should be able to justify why you did everything. And if you want to go a step further, ask yourself, why is this wrong? You know, start questioning your designs. Why is this wrong? Why is this not right? And if you can prove that your design is good, well then you kind of like covered your own ass. You know, if you need titanium fasteners because you're going to go to a very highly corrosive environment, well, you should be able to justify that. You know, versus using like black oxide and that's it. You know, you shouldn't always spec the most expensive material or etc. You know, if it doesn't need it, it doesn't need it. You know, there's a lot of plastic in this car here. You know, they could have made it out of like machined aluminum, but this car would cost like $2 million. Enter like a Pagani Huayra or something like that, or like a Bugatti Chiron with the, you know, the watch, you know, movement center cluster, yada yada. I think you're gonna learn how to, you know, go into a machine shop, use a lathe, a Bridgeport, sanders, grinders. There's also tools such as like deburrs. So maybe you'll make a machine part that has a lot of sharp edges on it. You'll throw it into like a machine that'll like deburr it. I mean, really depending on the industry you go into, I've used like circuit board manufacturing equipment, really specialization stuff. I've worked in clean rooms. The sky's the limit. It's why I prefer working in defense, because I was actually able to use all of my classes at my job. Whereas a lot of sales engineers, they're kind of like Excel sheet pushers, and they don't use a lot of their classes, and they're like, why do I even go to school for this if I don't even use my classes? The key takeaways that I want to give to you are like, don't expect again that you have to know like every equation. You can have your engineering books with you at all times, or you can Google stuff or look things up. A lot of times you may feel overqualified for your role, but the employer knows that, like, even though you're overqualified and you have so much information and knowledge as a mechanical engineer, and like a layman could do the job, and I've been there before, it's important to have a degree, because if shit goes left, you now have a huge knowledge base, a plethora of knowledge on how to fix it. You're an engineer. You can now engineer a solution with physics and math to back it up. So versus a layman, you know, anybody can build like an IKEA bookshelf but it takes a mechanical engineer. Oh, like why are these fasteners stripping out? You know, why is this bending? You know, why is IKEA bookshelf, you know, getting sad over time? Well, you know, like, you know, your section modulus wasn't big enough, you know, or whatever. You can use material selection to engineer a solution. It's a very simple example, but in industry, you'll come across situations where like things will break or not work, and you're like, well, what do we do? How do we fix it? Well, now you need an engineer. And because you're an engineer and you have all this knowledge, you'll know how to fix it. And also don't be afraid of like you're not gonna be the only person to like check your design. There's gonna be so many like design approvals on the thing that you're building or making that before it goes into production or deployment, it's been like signed off by like a lot more people with way more years of experience and industry knowledge. You know, even though you're a good engineer, they may say, hey, look, man, like I've been working here for 10 years and like, let me save you a headache, do this instead. And you go, oh, like, I wouldn't have known that. Let's see. Nice little tractor out today. Love that. If you have any questions on what it's like to be an engineer, mechanical engineer, in industry and profession, let me know in the comments below. I know I do plan to make some videos out here that answer some engineering questions to kind of like put your mind at ease. Like, I had so much stress and anxiety going into my first job as an engineer that if I had just talked to an engineer, I think I would have relieved a lot of that stress. You know, I do make these videos to help you guys out. I wish I would have had this knowledge, you know, back in the day. So I'm just trying to pay it forward. Let's see what we got. So, what else? Look at this guy. Please don't turn into my lane. Thank you. Could you imagine if he was like cranked over? You're gonna wear a lot of hats as an engineer, and it's gonna be a long, maybe a couple years before you get full authority of your designs. And they just say, hey, John, we need this, go design it. And like, you'll make the design, and like, it will be up to you to hold internal design review meetings. And by that, I mean, you'll take your design that you think you professionally made, and nothing's wrong with it, and you'll present it to all your mechanical engineering friends at work. And try not to take their feedback as criticism, but rather idea inputs. I personally have a hard time receiving criticism. I don't anymore, but in my early career, I was like, this is perfect. I'm like, what do you know? You know, like, I put so much design effort into this, like, how dare you critique me? They're all there on the same page and the same team to help you out and make sure that like the company wins. See you, bro. Let's see what we got. So when you present to these people, don't take things personally. A lot of times they're there to help you out and see things that you maybe overlooked. You know, for example, like galvanic corrosion is like, oh, I saw you use like an aluminum fastener, you know, on steel. You know, what was your plan for preventing corrosion over the long term? And you're like, what? You know, oh, I had no idea. Try to say like, oh, like, thank you for the input. I didn't think of that. Do you have any other advice? It's like the way I would structure that review, like, hey guys, this is my design, I'm looking for advice. I want this to be the best design it could be. Be humble as a junior entry-level engineer. Do not go in there thinking you know it all. Even if you do, just be humble. You'll never go wrong with being humble and literally asking for advice. A lot of times as well, like, you might be intimidated by senior engineers and asking them for advice, and maybe you're not intimidated and like good for you. I was, because I didn't want to look stupid. I was like, I can't ask John for advice. He's gonna think I'm an idiot. If someone makes you feel dumb, that's a toxic work environment. And I am sorry that you're going through that, but like, that's not how it should be. Additionally, everyone there is there to win and make sure that the product is the best it can be. At my current job, I feel like, everyone has a PhD at my current job and I don't. Not that I care about that, but the point being is, like, they're very smart and they know a lot about a certain subject and I don't. And so I'll go up to someone and say, hey, like, John, teach me more about XYZ. And they go, oh, like, come over here, have a seat. Let me get the whiteboard out and make sure you understand. And like, don't leave until you understand. And a lot of times these senior engineers and principal engineers, they're there to help you out. They're there to teach and mentor the younger staff. Because one day, like, you guys will advance and then new engineers come up, and it's going to be your job to teach the new engineers and take care of them. It's like a circle of life, so to speak. So you use a lot of SolidWorks, a lot of like CAD design. You'll use simulation. I was able to use like vibration analysis. So for example, let's say I'm designing an iPhone and I want to make sure that the little buzzer inside doesn't somehow like destroy the circuit board after 5 years of buzzing, or there's no like resonant frequency of that little buzzer. Well, like, because they don't put any vibrational motor in an iPhone. Like, they put a very specific one for a reason. So maybe in SolidWorks, you'll figure out like the resonant frequencies of circuit boards, and circuit boards have very small parts, obviously, down to like mils and microns. And if any of those connections get severed, well, now your device is broken. So you may run like a resonant frequency analysis in SolidWorks and then verify the design in simulation, and then you'll put it on a vibration table and run some vibration profile on that iPhone to then test what you learned in simulation to make sure that it works, so that when you go to ship it out across the world, Apple doesn't say in a year, oh, we're recalling all the iPhones because the vibration motor inside was spec'd to the wrong standard, and now we have like billions of dollars in rework to do, or we've like ruined our brand because we can't make a quality product. Think about the old iPhones that had those batteries that would expand, and it would push up against the glass and your iPhone would expand, and that's a mechanical engineer's job to figure that out. They should have accounted for that. Some chemistry in there as well, depending on like what battery you choose. But these are all things that you have to take into account as an engineer. And really, I really think that being a mechanical engineer is like the key to the castle. Everything that we see on this drive, pretty much a mechanical engineer like designed. Why do they choose these posts here? Why do they choose the wood? Why do they choose these transformers, the metal, the material selection, what, blah, 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 whatever. These mailboxes, injection molded, how do you design an injection molded mailbox? Well, you got to have a draft of like 2 degrees so that you can pull out of the mold, blah, blah, blah. These are all things that you have to take into account as a mechanical engineer. Don't think of my conversation here as I'm scaring you off, but rather what you're going to learn about the world. Because you will learn how to use equations in school, but you will learn how to apply them to the real world at your job. One thing I also want to say is getting a mechanical engineering degree is not easy. There are countless memes out there about, oh, like the business majors were partying, the art students were partying. Some art students, they did a lot of work, but like finance majors were partying, the lit majors were partying, sociology majors were partying. Engineers, they were crying in the library every night, okay? So what I'm trying to say here is that you went through one of the most rigorous educational program of 4 years. Like, you are not an average citizen of society. A lot of times I say that my master's degree in mechanical engineering was a master's of perseverance, because this shit was hard AF. And so the fact that you could balance, working full time while going to school full time, and you passed, that is a testament to you as a human and your character and what you're able to do. They don't hand out mechanical engineering degrees like they're going out of style. It's very hard to get an engineering degree in mechanical engineering and other disciplines as well. I mean, there's a reason why like the drop rate of freshmen is like 60, 70%. Like everyone can take Calc 1 and Calc 2, but like you start getting into like dynamics, and like vibration analysis, toast, weed it out, done. It separates those who are willing to work hard and those who are willing to just give up. So having a mechanical engineering degree, like every time I talk to a mechanical engineer in public or randomly, I'm like, dude, like you're a hard worker. Like you put in a lot of work, and you know a lot about the world, and you're going to be savvy. Things that will help you out as well as a mechanical engineer, being hands-on, like being able to have like built things. I work on all my cars myself. Everything from an engine oil change to literally rebuilding transmissions and diagnosing them, or engine rebuild, etc. That goes a long way. People think that, oh, like you're into cars and a mechanic because you're an engineer. I'm like, no. Like you hand an engineer a screwdriver, they're like, what is this? I don't know how to use this. So just being a little hands-on helps out. It'll help you out. It'll make you not be like all thumbs in industry. I see a lot of people in machine shops doing really dangerous stuff or really wonky, backwards practices, and I'm like, did anyone teach you how to use a screwdriver? Like what are you doing? Anyways, I'll throw that out there. It's not a requirement, but it will help you out in the long run. What else? Let's see. What are some things I wish I knew starting? I worked a lot. I was always there to take on as many projects as possible. I was like everyone's go-to person for projects or help, or I would ask RF engineers, electrical engineers, radiation, engineers, like, oh, like let me help you out with that, and I would start to learn multidisciplinary things, so that when I go to do my mechanical design, I'm thinking ahead, so that when electrical gets this, they're like, why would you not give us any space for our circuit board? This is impossible. Or an RF engineer, like, why would you make this enclosure solid metal? This is a Faraday cage. Like, go redesign it. So it's nice. You start to think, about the world from other disciplines, and you'll learn. So you'll use PowerPoint, you'll use Excel, SolidWorks, any Microsoft tool, Outlook, emails, whatever. You might have a lot of meetings with other teams, and just you'll do a lot of like status updates as well. Additionally, once again, you should be able to defend your design at any point. Like a really good engineer should be able to field any question from the audience and be able to not only answer it, but if the audience, digs one step deeper, you should be able to back it up with formula. Yeah, that would be a great engineer. Let's see. Yeah, I mean, pretty much get ready to like wear any hat. And if you feel like you're not growing at your current job, or you're not getting done what you want to do, ask your boss. Say, hey boss, like I really want to work on XYZ. Do you mind if like on the next project we can incorporate that? And make sure you speak up for yourself, because your boss is not a mind reader and they don't know what you want to do unless you speak up. So if you really want to be in the machine shop and learn machining stuff, or a CNC, or like how to use like and you want to learn how to use a CNC, well, tell your boss that, and they'll incorporate you, in there. Try to make yourself like indispensable. Everyone is dispensable and replaceable. Like, don't ever think you're not replaceable. A lot of engineers, you can just like swap them out for other engineers. So the more indisposable you become, you'll have more job security and safety, etc. Let's see what else. Ask for help from other engineers. Don't be afraid to ask for help. Also work with your colleagues a lot. Help them out, give them advice, etc. Like, make friends, because just because today you work together doesn't mean tomorrow you won't. And they go to, company B, company C, D, E, F, G. And if you made 8 friends at your first job, well, best case scenario, you now have an in at 8 different companies in the future. And as I mentioned in my original video, once you have an in at the company, you're pretty much guaranteed an interview at that job, and you have an internal referral. Like, oh yeah, like, used to work with John back in the day. John was a great asset. John was really nice. John was a good engineer. We should interview him. You get interviewed, you talk, yada yada. More often than not, you'll get the job, unless like you're just really off base. Like for example, like if you're applying for an engineering role at SolidWorks heavy, and you never touched SolidWorks in your life, well, like forget about it. I can't help you out. So definitely still make friends. At my second job, I knew no one, and then I was on my own island for like 3 years. Never once came across an old employee. And one day, I was off-site somewhere, and I ran into an old coworker, and I was like, oh my God. Again, John, like, so good to see you. What are you doing these days? Oh, I'm doing XYZ. Oh, that's amazing. I'd love to work with you. Is there a spot open? Oh yeah, sure there is. Let me ask my boss. Done. So, network, help people out, give back, pay things forward, etc. Participate in like company events, social hours, whatever. Today, at my current job, I don't do the social hour stuff after work. It's not paid, and I respectfully already know a lot of people in the industry. So for me to spend an hour, at a happy hour, and then be stuck in like 5 p.m. bumper to bumper traffic, like, it's not for me. Like, I don't really need it. What else? And I'm telling you, you just never know who you'll run across in the future in your career, or people you'll have to call back and say, hey man, like, looking for a job, like, you think you can help me out? But so many referrals happen that way. Let's see. Be enthusiastic at your first job. Just the more enthusiastic you are and willing to learn, the more engineers are going to like you. You'll end up being like the go-to hard worker, engineer, the team asset, etc. And like, it's a really good spot to be, not only will you teach yourself more by taking on more, but once again, you're going to become more valuable at the organization. With that being said, there is no guarantee of a promotion, a raise, recognition, etc. So also balance that as well. If you do want a raise or a promotion, communicate with your boss. Say, hey, John, I'd love to work on this project. I'm looking to get a raise. How do I become a senior engineer? What are the qualifications for a promotion? And HR should have bullet points on how to get that promotion. If you're lucky, it's objective stuff. And it's like 3 years experience, led a project, blah, blah, blah. Versus like subjective where it's like, is a master in the subject? Well, like, what's a master in the subject? That's very subjective, and there's no guarantee that you're going to be one man's master is another man's like layman. So balance that too. Yeah, oftentimes your first job is like the most fun. You really get to use your classes every day, hopefully, and I hope for you guys out there. But if you feel like you're stuck and you're not progressing, don't think that staying is going to make everything better. Because, try to make it work at your current job. But, it comes a point where it's just not going to work anymore. So that's all I have to say about that. Let's see. I think it's going to conclude our video for today. I wish I was offering some secret kernel of advice, but I wanted just to share my story of what it was like to be an engineer for 3 years at my first job, and what I was scared of versus what reality was like. Again, I was really scared that I had to know all my equations at all times. Spit back, these like deep physics equations to us like this. It's not happening. So that relieves a lot of pressure off. Also, if you get hired, then that means that the hiring team felt you were qualified for the job. So a lot of times engineers will have imposter syndrome, like, how did I get here? I don't deserve to be here. My neighbor is smarter than me. My classmate is smarter than me. Don't sandbag yourself too much. Again, perseverance and just showing up every day and trying and showing interest and grit goes a long way. I'll just say that. Once again, if you have any questions, put them in the comments below. I hope this video helped you out. Just want to, again, document what it was like to be a 1-year mechanical engineer, expectations versus reality. I really enjoyed it. You start ramping up really fast, and it's really fun that when like the new kids come in, you now get to like teach them. And then as you teach them, you will learn yourself, because you don't want to give a new fish bad information or bad advice. So once you start to teach, you really make sure what you know is good intel. So on and so forth. Consider subscribing to the channel. Once again, if you leave video ideas in the comments, I'm happy to answer them in like one fell swoop. And we'll see you next time, guys. Thanks for watching. One more thing. Let's talk about schedules real quick. A lot of companies will have core hours, and that's kind of like you must be on site during these times. So I had one job, core hours were from 9 a.m. to 3 p.m. And then other than that, you could work from home as needed. I think the best jobs are hybrid work environment where you have the option to work from home if needed. And then for things that have to be on site, you do it on site. So you can get some flexibility. If it were up to me, I would go for a job that was hybrid, flexible schedule. There's a lot of jobs out there that are like, make your own hours as long as the work gets done. That's great. I think the worst job ever would be like, you must be here from 9 to 5. No questions asked. I would hate that. So my second job that I had, if my first job was extremely math and engineering, equation heavy, simulation based, my second job was the opposite. I want to say respectfully, it was like the Home Depot of engineering. There is a time and a place where you need to invest a lot of hours in simulation, equations, etc., improving the math, analysis, whatever. For example, like a satellite, because once it goes up, it's not coming down, you know, and it's very expensive to launch a satellite and make sure that all the parts on there go to space, whatever. Versus this little iPhone mount here, dude, I can bend some sheet metal, do a little rubber thing, yada yada, a magnet, out the door. Simulation, not needed. Big extremes here. So at my second job, they needed mechanical engineers on staff, but there wasn't a lot of heavy math and engineering to prove your design to work. Often all you needed was like a little rule of thumb, a little, like should be good. Like a should be good as qualified by a mechanical engineer was good enough. And so if you're smart enough as a mechanical engineer, you can just like look at something and say, here's what we need. Done. No more hours being billed on the analysis, and then what you say goes. I think that's pretty rare for jobs. I don't know, you guys, let me know in the comments out there. But I just wanted to bring it to light. With that being said, at that job, if shit went left, you needed all your equations to now attack the problem in all your classes. Oh, like, why did this fail? Why is it not working? Why is this overheating? Why did this pipe burst? Is this a material design problem? Pressure vessel, yada yada. You know, like you're starting to now think of all your classes of why this design failed or didn't work. It's very lazy and expensive engineering to design something and be like, like it should work, and like designing and like resting on like it failing to then warrant a new design change. So my first boss told me that 3D printers made bad engineers because, like if it doesn't fit, I'll just have a new part printed by tomorrow, like whatever. Like it creates lazy engineers. But oftentimes more than not, you can be a lazy engineer for certain applications. At my second job, you know, it was a lot of it was just like, because I'm an engineer, this will work. Depending on the severity of the outcome, obviously if lives are at stake, you know, like a bridge or an airplane or, you know, a seatbelt or whatever, you know, like, yeah, you're gonna use a lot of analysis. But again, like this iPhone mount here, you know, dude, you don't need to analyze that. So the point of the story is like, know when you take a deep dive and run an analysis, and also know when you can just do like first pass, should work, should be good. There's a really funny, famous quote out there where it's like, my design worked in SolidWorks. You know, famous last words as an engineer. Like, just because it works in SolidWorks doesn't mean that it's gonna work, you know, somewhere else. So anyways, I just wanted to add that little tidbit in there. Then at my current job that I run, like, I have no SolidWorks, I have no simulation, I don't do any analysis stuff. It's extremely math, like the work we do is like math heavy. However, a lot of what I do is I actually check other people's work. So it's kind of like up to me to give like a thumbs up of approval, saying like, hey, like the analysis that this person did, it looks good, like it checks out. Or like if it's really off, they got to revisit this. So I'll just say that. That's a nice house. All right, yeah, so anyways, once again, if you have any questions that you want to ask me as an industry engineer, feel free to ask. I know it can be tough out there to like know industry engineer if you're like young, maybe like your parents are like, you know, not engineers and you can't ask them for advice, or you don't have any older friends who are mechanical engineers that you can ask for advice or questions, whatever. So ask away. I love the comments. You know, if we had to take a deeper dive, you know, we can run over to email. This video helped you out, consider giving it a thumbs up, also subscribing. You know, I'll run a little ad at the end of this video for ways to support this channel. And yeah, guys, good luck out there. And again, be very proud of yourself that you're a mechanical engineer or an engineer in general. Anybody watching this, any engineer watching this, be proud of yourself. You work very hard and you're very smart and you're very capable. So, see ya. Hey guys, thanks for watching today. If you want a nice black 100% cotton t-shirt in either black or white, you can head over to my clothing store, link below. It's through a company called Fourth Wall. To be honest, I'm only selling things I don't want to wear myself, which include just plain black and white t-shirts, which you can see right here. If you want to be a really OG gangsta supporter, you can get some Das Cayman Swagoo. Alternatively, if you want to support the channel with my Patreon, we love that as well. And your tier gets your name advertised and a press support shout out in each video. And other tiers even go up to private one-on-one phone calls, giving advice related to either cars, life, or advancing your career. Thanks again for watching, and we'll see you next time.